of our test review. So starting with lesson 3-4 now, we're on to the part where we're going to construct functions to model linear relationships. So, two parts to this one. The first is one of the more difficult things that we have done in this class, okay? It says, what is the equation of the line that passes through 0.5, 4.25, and 2, 18.5, and has a y-intercept of negative 0.5. Okay, for every equation, what two things do we need? Go, Jermaine.
We'll need to stack the numbers on top of each other and see what numbers go with what numbers. So
Yes, do you remember what that's called? Finding the what?
finding the y-intercept.
And the?
The
Starts with an S?
Oh, and the slope.
And the slope. Okay, so every single one, when it says what is the equation, that's the main word here, okay? You are looking for a slope, and we are using M for that, and a y-intercept. Okay, to find the slope, we've actually already did the equation for slope from the table earlier. What was the equation again? It's the same exact equation for this one that it was for the last one. What's the equation? I'll start it for you. y2 minus y1 divided by
x2 minus x1.
Perfect. Okay, so that's what we're going to start with. In this case, when they list the ordered pairs out for you, it means they go in order. So I'm going to rewrite them because I did my marker there. But 0.5, 4.25 is our first ordered pair. So that would be x1, y1. Our second ordered pair in the list is 2, 18.5. So that would be x2, y2. And so you use those numbers in the formula, okay? So we're going to do, what do I subtract then on the top? Who knows what I subtract on the top of the fraction? Liliana, go.
18.5 and then 0.5.
Yes, 18.5 minus 0.5. Who knows what I subtract on the bottom of the fraction now? What goes on the bottom? What two numbers? What's my x2 minus my x1? Go, Emma.
2 minus 4.25.
Yep.
Wait,
No.
no, I did it wrong.
Oh, Liliana did it wrong. I'm
Yeah.
sorry. It should be 18.5 minus what, Liliana?
Minus 4.25.
Okay, yep. And then you're right, Emma. 2 minus 0.5. I think you were going to go for that in the beginning, but then we had the wrong answer. Okay. So you're probably going to want to use a calculator here to make sure that you are correct. What is 18.5 minus 4.25? Marty, go.
14.25.
Okay. Who's got the bottom? 2 minus 0.5, Domenico, go.
1.5.
1.5. Now, on this, you need to divide it in the end so that you get an answer that is not a decimal over a decimal. And Adina, what'd you get? 9.5. Sorry, I ran out of space, so I'm going to write it here. So this is my M. Now, in this case, does it tell you the B value? What is it? Yeah, it tells you it right in the question. It says this is the y-intercept. See it? So it's got to be negative 0.5. Okay, who can write the equation now? I'll start it for you. Y equals. Go, Jo Marie.
9.5x minus 0.5.
Perfect. Could you have put y equals 9.5x plus negative 0.5 as well? Does that also work? It does, okay? The shortened version is really what most of the time we see. Okay, number 2 is also from this section. It says the graph shows the relationship of the number of gallons being drained from an aquarium over time. What function models the relationship? Okay, when it says in this case, It also is asking, function is another word for equation here. So we still need an M and a B. How do you find M on a graph? What do we need to do? And this one is a little bit, it looks as if it got cut off a little bit here, so I apologize. But 100 would be here, so this is 90. And then 10 would be here, so this spot would be 9, okay? So fill that in. So right here, it's hitting at 90. Right here, it's hitting at 9. Is that clear? Put that in. Okay, so M on a graph starts with an R and an R. What will we do on a graph with an R and an R? Go ahead, Domenico.
Rate.
Nope, not rate. That is it. But what on a graph? I'm looking for something else. Sadi, go. Rise over run. Rate is also correct, actually. So rise over run. Is it okay for me to use this dot and this dot? Yeah. So is my rise going to be positive or negative? If I start on the left, it's negative because I'm traveling down. How far down is this? Use the scale. If I started at 90 and I travel all the way down to 0, what is that worth? Yes, and it's negative 90, right? And then what is this worth if I travel from 0 all the way to 9? 9. If I divide that, what is negative 90 divided by 9? Jaden, what is it?
10.
Positive or negative?
Positive.
Try again.
Oh, negative.
Negative, okay? So negative 10 is my M. Okay, now on a graph, you should be able to just look at that graph and get this answer. What is my B value or my y-intercept? Where does that guy hit? Go ahead.
90.
Yes. See how it hits right at 90? B value also means y-intercept. This is my y-line. That's your y-intercept. Okay, I have both things that I need. Somebody tell me the final answer. What is the equation now for the graph? Emma, go ahead.
Y equals negative 10x plus 9.
Perfect. Excellent job. So those are worth multiple points, right, on a test because I'm going to ask you to find M, I'm going to ask you to find B, and I'm going to ask you for the equation. So 3 different points for one question. All right, we are almost done. Ooh, whoa. All right, the last page are the last 2 things that we ended with. So 3.5 was about intervals, and 3.6 was about sketching them, okay? So I copied for you this. I copied for you this graph. It says the graph shows the altitude of an airplane over time, right? And so it says which intervals is the graph of the function constant? So if you look at that graph, who can tell me which intervals are constant? Gloria, go ahead. 2, I agree with 2. 2 is constant because it's flat, right? And which one? And 6. There's one more.
4.
And 4. Okay? Constant means that it's got it, and if we have to explain, what's our because here? How do we know that those 3 are constant? What are we looking for? They are flat. Oh, wow, I can spell flat. Which means that the slope there is 0, right? Okay, good. That's a pretty easy question to get correct, right? If you know that. All right, number 2. In which intervals is the graph of the function decreasing? Now remember, I want you, some of you get confused here because you read the graph the wrong way. We are reading the graph from left to right. So if this is an airplane, what's happening in 1? It's increasing. Then it's flying. What's happening then in 3? Increasing again. So where are the decreasing intervals? Cameron, go. 5 and 7 are the ones. So it's coming back down in 5 and 7.
put 7 and 5, would that still count?
That still counts. Yep. The order doesn't really matter here. It's just asking you which ones are decreasing. How do you know? What's the because?
They're going down.
Yes, they are traveling down. Okay, and so what would the slope be, positive or negative here?
Negative.
Okay, good. So that means slope would be negative. We don't know the slope, we just know that it would be something negative. And sometimes you don't need to be so specific on some of the questions, right? If we know the slope is negative, it gives us information that it's going down. If this is an airplane, right, it's then landing at 7. Okay, last but not least, and again, this one's worth several points on a test because there are parts that you have to get correct. All right, Jack's mother brings him a bowl of carrots as a snack. At first, he does not eat any. Then he eats one at a time until half of the carrots are gone. Then he does not eat any more. Sketch a graph that shows the number of carrots in the bowl over time. Okay, first and foremost, before we sketch the graph, what are my independent and dependent variables? Which is which here? One of them is independent, one of them is dependent. Which is which? Marty, go.
Independent is X.
Our X. So what is the word on the X? Time. Good. Time is independent, and she's actually absolutely right that we look for independent to be the X values, which means dependent has to be what this time? Our Y, his number of carrots that he ate. Okay, so let's talk about this. This was a weird one. So we're going to sketch this graph. Go piece by piece. It says at first he does not eat any, right? So starting here, where does the line go at first? It's constant right at the bottom. He eats 0 of them, right? Then he eats one at a time, and I'm going to color code this. He eats one at a time until half of the carrots are gone. So what's going on now? It's going up for a while, and it's constant. It's staying, right? Then he does not eat anymore. So does it go down or stay constant? It stays constant. Does it ever go down? No. So that's something we have to be cognizant of, is that our brains always want a graph to go back down, but they don't always go back down. All right, and this is how we would do that graph. Okay, are there questions on that? Yes, sir.
Wouldn't it start at the top, because that would be 0. So the number of carrots,
So it depends on how you look at that, right? So it is saying sketch that shows the number of carrots in the bowl over time. Oh yeah, I guess it would go the other way, wouldn't it? Yep, because it said in the bowl. So we would actually have to start it the other way. But we're going to leave it. We'll change this. That shows the number of carrots. We'll say he ate. But good point, Domenico. Very good. So we'll change it to match what we've done so we don't have to redo it for our video. But I will point that out on a test, which way that's going to go if we have a problem. Okay, people who are watching the video from my class, if you have questions, please email me before that test tomorrow.